Side lobe level and front to back ratio are the two main parameters that we consider during the antenna design. This video explores more details about side lobe level and front to back ratio. When we consider a radiation pattern, we know that it has major lobes and minor lobes. So most of the energy is concentrated in the major lobes, and these minor lobes are actually unwanted or undesired lobes. The main issue with these minor lobes is that they will also transmit and receive the signal. So this will cause interference and increase in the noise level. So it is actually undesirable, but it is not practical to design an antenna without any minor lobes. So while designing the antenna, we know that it will be having the major lobe and minor lobes. So we have to make sure that the designed antenna performance is optimized and energy is efficiently used. That is, the most of the energy is concentrated in the major lobes, and these minor lobe levels are very less, so that it will be uh, not providing that much interference. So to measure these things, we have some parameters, and these are side lobe level, front to back lobe ratio, and beam efficiency. The side lobe is the strongest main lobe. It usually happens near to the major lobe. This side lobe level gives an indication about the level of the side lobe with respect to the major lobe. So it is defined as side lobe level is side lobe in dB minus main lobe. If you consider a Cartesian radiation pattern, we can see that this is the main lobe and these all are the minor lobes, and this is the strongest minor lobe, and it is, that means it is the side lobe which is happening near to the main lobe, and this is the maximum level of side lobe. So the difference between this side lobe and the main lobe is known as the side lobe level. So if we are getting a side lobe level like this means that side lobe level is getting decreased. So it is very desirable to have the lower side lobe level. So if you have a side lobe level of around minus 20 dB, it is very good. That's the indication of side lobe level. It gives an indication about how much side lobe is occurring with respect to the major lobe. The minor lobe, which is happening just opposite to the major lobe, is known as the back lobe. So the front to back ratio gives an indication about the level of the back lobe with respect to the major lobe. So it is defined as main lobe level minus back lobe level. So in an ideal condition, we don't require any back lobe level. We require only the main lobe. That means that the back lobe level has to be 0 or front to back ratio has to be very high value. So the high level of front to back lobe ratio is required. So if we consider a 2D radiation pattern like this, that is just unfolding this 3D pattern into a 2D pattern, here we can see that this is our main lobe, and when we unfold this pattern, this back lobe level will be appearing at 90-degree, and this is our back lobe level. So the difference between this and this gives an indication about the front to back ratio. So our requirement is reduction in the back lobe. So we will be getting higher front to back lobe ratio. We have seen that we have side lobe levels and front to back ratio to indicate the level of the minor lobes with respect to the major lobe. But in case of a side lobe level, we are considering the major lobe and the side lobe level. So this difference is we have taken as the side lobe level. We are considering only 2 points, that is the maximum power in the major lobe and the maximum power in the side lobe is considered to calculate the side lobe level. In case of front to back ratio, similarly the maximum power in the major lobe and the maximum power in the back lobe is considered to calculate the front to back ratio. So this means that we are considering only a single point power or the maximum power to calculate these values. But we know that there are other minor lobes other than the side lobe and back lobe level, which can also accept or transmit the power. These minor lobes can also cause the interference and the increase in the noise floor level. So we have to consider all the minor lobes together to get an indication about the efficiency of our antenna, like whether all the energy is mainly concentrated in the major lobe or is there any leakages through these minor lobes. For that, we have to analyze the radiation pattern in 3D. So for that, we are using the parameter known as the beam efficiency. In case of beam efficiency, it will be considering the 3D pattern and the 3D major lobe and 3D minor lobes. So our next video will be explaining about the beam efficiency. Thank you. If you find any of our videos useful, kindly support by liking, commenting, sharing, and subscribing.